Hello and welcome to this video on network conversion. So in this video, I'll be showing you a shortcut on how to convert a star network into a delta network using the given question displaying on your screen. So the question says, convert the given star network into an equivalent delta network. Okay, so we are simply to convert this into a delta network. Okay. Alright, so under this given condition, and our equivalent delta network will look like this. So I've made a separate video on this earlier on how to convert a delta network into a star network. You can do well to watch that video, because at the end of that video we also showed how to convert a star network into a delta network. Now, in the previous video I said to do this, all you need to do is draw your equivalent delta network. So you draw your delta network. Okay, this is our delta network. Okay, now having drawn your delta network, then you draw the star network, the given star network, inside the delta network. So this is our star network. Okay, so you draw this given star network into the delta network. So if you do that, you're going to have this. So these are star network inside the delta network. Now let's label them, not forgetting from the given question. Here is 10, this is 20, and this is 30 ohms. So let's label accordingly. So we have here to be 10 ohms. Okay, 10. We have here to be 20 ohms, 20. We have here to be 30 ohms, 30. All right. So let's call this RA unknown. Let's call this RB unknown. Let's call this RC unknown. And we need to find the equivalent values of RA, RB, and RC to be able to convert this star into a delta network. Now, I said in the previous video, in order to find RA, okay, let's start with RA. In order to find RA, I said you look for the loop that forms a close and complete triangle with RA. Now, the loop that forms a complete triangle with RA involves from here to this point, and this. So this is our complete triangle. This is the loop that forms a complete triangle with RA. And on this loop, we have 30 ohms and we have 20 ohms. So you find the sum of 30 and 20. That gives you 30 ohms plus 20 ohms. Plus, next you find the product of 30 and 20. So you have 30 times 20. Divide this now by the given resistor in the star network, which is not among the triangle. So the resistor which is not among the triangle is simply the 10 ohm resistor. This is a complete triangle involving 20 ohms and 30 ohms. So the 10 ohm resistor is not among. For that reason, you simply divide this multiple by 10. Okay, so whatever value you obtain here becomes your RA, and this is equal to 30 plus 20 gives us 50, plus, now let's find 30 times 20 divides by 10. That simply gives us 60. Okay, so this simply implies that our RA is actually 110 ohms. Okay, so the value of RA has been found. Similarly, to find RB, this is equal to, also look at the RB, look at the circuit, find the equivalent loop which forms a complete triangle with RB. So if you take a look at the circuit, this is RB, The loop which forms a complete triangle involves this from here to here to here. This is forming a complete triangle with RB. And the only resistor involved there are 20 and the 10 ohm resistor. So once again, you add them together, 20 plus 10. Now plus, find the multiple of the two, 20 times 10. Divide this value now by the resistor which is not part of that triangle. Okay, so this is a complete triangle with RB. The resistor which is not part of this triangle is simply what? The 30 ohm resistor. So we simply divide by 30. So this simply implies that RB is equal to, of course, 20 plus 10 gives us 30 plus 20 times 10 divided by 30. Let's obtain that value. That simply gives us approximately 6.7 or 67. Okay, so this simply implies that RB is actually 36.67 ohms, and you have this. Finally, we find RC. Okay, so to find RC is still basically the same approach. So I'm sure you can do this by now. RC is equal to, okay, so to find RC, you find the triangle or the loop which forms a complete triangle with RC. So which is simply from here to here to this point, that forms a complete triangle with RC. And the resistors involved there are the 30 ohm resistor and the 10 ohm resistor. So you find the sum of the resistor. So we have 30 plus 10 plus, now you find their multiple, 30 times 10. Divide this now by the resistor which is not part of that loop or that triangle. So this is our triangle, 30, 10 and RC. So this resistor is not part of the triangle. So the resistor which is not part of that triangle is a 20 ohm resistor. So you're dividing through by 20. So you simply have 30 times 10 divided by 20. So this is equal to, now 30 plus 10 simply gives us 40 plus 30 times 10 divided by 20. That simply gives us 15. So 40 plus 15 gives us 55 ohms. So resistor at C is actually 55. Alright, so having done with this now, let's draw our equivalent delta network. So not forgetting, we had this. Guide a finger aside. Guide a finger aside. Okay, now let's fit in our values. This is RA, this is RB, and this is RC. Okay, so here RC is gotten as 55. So here is 55 ohms. Okay, RB, we obtain RB as 36.67. This is RB 36.67 ohms, and we obtain RA earlier. We obtain RA as 110. So we simply plug it in, 110 ohms. Alright, so this is the equivalent delta network of the given star connection. Alright guys, so that's it on star delta conversion. Please, if you're new to the channel, do well to appreciate our work by liking our videos, commenting nicely, sharing these videos to your friends and colleagues, and of course subscribe if you're new to the channel. I will see you in the next video. Thanks and cheers.